All right, so this problem says, design a solenoid that will produce a magnetic field of 0.05 teslas if it has a current of 15 amps running through it. They give us the radius of the solenoid, 7 centimeters, and they also say how long the solenoid is, 3.2 meters. So when they say it's 3.2 meters long, they mean this distance. That would be the length of the solenoid. So that's 3.2 meters. The radius is going to be the distance from that central axis to the coil itself. So that's R. That's 0.07 meters. Now what happens inside a solenoid when there's a current running through it is it makes a nice uniform magnetic field. Okay, so let's say you just hook up the solenoid to a battery. And it's got a current of 15 amps running through it. So what we can do is we can actually grab the solenoid, imagine grabbing it with the right hand, in order to determine what the magnetic field direction is inside the coil. You have to let your thumb point in the direction of current, though. So current is going to flow out of the solenoid on this side, and it flows into the solenoid on the left side. So you have to imagine grabbing the wire somewhere. So let's say that you grab it so that your thumb is pointing down. If your thumb's pointing down, then your fingers are going to wrap around the coil this way. Okay, so see how I grabbed hold of the wire with my right hand. Now the fingers are going to go through the inside of the coil. And so that's going to be the magnetic field that's created by this coil. It's going to come out of the middle of the solenoid, like this. And by that same idea, field lines are going to come into the solenoid on the other side, like this. And the idea is when you have a current going through a coil, it's similar to having a bar magnet of north and south. All right, now when we had looked at magnets in the past, we said that field lines will leave the north side of a bar magnet, and then the field by convention would be coming into the south side. So the same thing will happen here. It's like a magnet. But the strength of the field that it creates will be mu naught times N times I over L. All right, that's the B of a solenoid. All right, so we just want to plug in our numbers. N stands for the number of turns. But I see in this problem, we don't know how many turns there are going to be yet. But we do know the current. And we do know the length. Now we'll replace the magnetic field with what they want it to be. They want a magnetic field of 0.05 teslas. And now we can solve for n. It tells us how many coils we have to have, like how many times we have to wrap this thing around in order to create the effect that they want. I'm getting 8,500 turns. Which is a lot of turns. So one thing they'll do with these solenoids is they'll often coat the wire in some kind of plastic coating which won't conduct electricity so that you can keep winding it and winding it, you know. You certainly don't want the metal to touch metal, which you don't want.